Okay, good evening. Today we looked at some very basic algebra equations, solving equations that involve addition and some multiplication. And so quick little recap of about our number line. We got ourselves a 0 and we got numbers increasing to the right. If we're talking about natural numbers, we have the numbers 1, 2, 3, etc. And each of them has a negative counterpart. Negative 2 is called the negation of 2, and 2 is the negation of negative 2. They're each other's nemesis regarding addition and subtraction. So we talk about an inverse numerical operation when we speak about what will do the opposite. What will be the inverse of adding 2? The inverse of adding 2 is subtracting 2. So if we look at the very first question as homework, it's a plus 2 equals 3. So the policy we have, the strategy we have is to isolate a, get a on its own. The problem is a is currently having 2 added to it, and the answer is 3. So the strategy is to inverse the process of adding 2, is to subtract 2. If I do it on the left, I'll do it on the right. But if we look at the result of that, they cancel, and you do the computation, you get 1. But we can see through all of this process of subtracting 2 at both sides. We can see through it and see that the net outcome is that we brought the 2 across and changed sign. That's another way of seeing it. So we can go a equals 3 and the 2 goes hopping across to become negative 2. Calculating that out, you get the first answer is a equals 1. Great. So overall, we're going to be inversing, and you can inverse all the 3 operations. What's the inversing of multiplying by 3? It's dividing by 3. What's the inverse of minusing 4? It's adding 4. What's the inverse of dividing by 7? It's multiplying by 7. And we'll see all of these things as we work. And then when we do inverse a particular type of operation in mathematics, the 4 main operations you know about going in is plus, minus, multiplication and division. Later powering comes on, but really if we can conquer these 4, we're doing very well, and we're on our way. Okay, so the special word for inversing plus or minus, the special word for that is negating. So today is all about negating. It's really, really simple. So we go ahead and start doing some negating. So b plus 2 equals 2. So I'll negate this 2, bringing it across, and I'll get b equals 0. That's 2 done. C plus 2 equals 1. Negating the 2, getting it across. Get rid of it there. C equals negative 1. D plus 2 equals 0. Negate the 2. Answer negative 2. I'll just jump back up this way now, if you don't mind. So if we wanted to get a fancy expression, maths expression for what we're doing negation of a constant to solve a linear equation. Oh, my computer's gone to sleep. Oh, this isn't good. So we got down as far as D. For E, we have E plus 2 equals negative 1. Negate the 2. E equals negative 3. That'll be negative 1, negative 2. F plus 4 equals 2. Negate the 4. F equals 2 take 4. That's equal to negative 2. Now, if you were ambitious, had a positive, had a productive disposition, you'd keep going. I said the minimum amount might be in 4 or 6 depending on what class you're in, but nothing to stop you keeping going. And you could subtract 4 and get -6. That would be negating the 4. H plus 3 equals 4, H equals 1. I plus 3 equals -4. Over it goes, equals negative, that's -7. We go to part 2. Okay, so this time we'll use the first example. 2a, 2 times a number plus 5 equals 1. So the first thing we do is we go ahead and recognize that we do want to deal, there's 2 processes going on. A is getting doubled and it's having 5 added to it. But in order to unravel this mess, and the answer is 1. But in order to unravel this mess, the first thing you want to unravel is the 5, and then we'll tackle the fact that there's double. So 2a equals -4. 1 take 5 is 4, is -4. And now we'll deal with and we'll discuss this process of, if you have a number in the number line, we'll call it a. Now where it belongs doesn't matter. It might be back here, it could be negative, it could be positive. But when you have a number called a on the number line, and you double it, you are repeating that jump, but it's what is called, it's a relative step. So it's relative to how big a was. And if a happened to have been here, and it doesn't have to be called negative, a could have been a negative number, it's a variable, then you will repeat that. And if it had been treble a, you have to consider this relative jump. So the difference between this operation and the absolute operation of adding 2 is that it didn't matter if you were at a and you were adding 2 to it. It didn't matter what size a was, and it didn't matter if it was negative or positive. You were just going, I'm going to move up 2 on the number line. That's called an absolute step, and this is a relative step. And the opposite, the way to negate, and or the way to inverse, sorry, I shouldn't use the negate word. The way to inverse the doubling is to divide by 2. Okay? The way to undo what you've done. Hey, I used to be here, now I'm here. Why the hell? How did I get here? The way to negate it is to divide by 2. And the way we see that happening is literally that this 2 goes down here. A lot of students get confused about when it looked like this came across and became negative, and when it looks like this, the 2 goes down. How are you supposed to tell the difference? And the difference is there was no plus in here. This was a multiplication. This 2 represented multiplication by 2. Very, very different. And we want to develop the concept of the 2 dividing down and generating a fraction at the far side, which may, and in this case it does, simplify to an integer. So I want that 2 coming out and going like so. Examples. Let's do more examples. Second one there, 2b plus 9 equals 3. I'm going to subtract the 9 first of all. 2b equals -6. Now I'm going to divide down to 2. b equals -6 over 2. Okay, so we say that the inverse, which is the general word we always want for any operation, the inverse of multiplication by some number like b, or by the number 2, the inverse of multiplication is division. And that explains divide by 2. I'm I'm pausing because I want to develop all the. I want you to develop all the different vocabulary. And when you divided, inverse of multiplication is division. When I go back to the previous one, we talked about negation. And you negate a term by taking it to the far side and switching it. That is or just negating any term. Negate 5, negative 5. Negate 7, negative 7. Negate negative 3, 3. So, but that word negate has gone off the table now when it comes to dividing. We don't use that word anymore at all for this. In this word we talk about reciprocating. That's the one I wanted. That's why I spent the last few minutes kind of messing around. I'm waiting to give you this brilliant word, reciprocation. Reciprocation. Okay, so the reciprocal of 2 is 1 over 2. Reciprocal of 1 over 3 is 3. We'll see that come later when we have something like b over 3 equals 7. Reciprocal of a third, so that 3 will come up to multiply. You say, okay, instead of dividing by 3 here, I'm going to multiply by 3 here. Scratch that, you get b equals 21, which would be correct. Okay, so the wording I'm going to keep using is reciprocation. So I've gone ahead and I've reciprocated down to 2, and I'm ending at getting b equals negative 3. The next question is 3c plus 4 equals 1. 3c plus 4 equals 1. Negate the 4. 3c equals negative 3. Reciprocate the 3 down. I don't have to say down, but it makes us understand it a little bit better for now. And then go ahead and compute that. That's equal to negative 1. Okay, I like the way this is done because it's A, B, C, D. You know that was the third question, because C is the third letter and you have. I'll make up my own question similarly to this shortly, if I don't have what I want from the book. So 5d plus 10 equals 0. Negate the 10. 5d equals negative 10. Reciprocate the 5. d equals negative 10 over 5. Calculate negative 2. That's d. (3e) plus 2 equals negative 4. Negate 3e equals negative 6. That would be negative 4, negative 2 is negative 6. Reciprocate e equals negative 6 over 3, which is equal to negative 2. Hey, they're throwing an x in all of a sudden. 4x, a, b, c, d, e. It should have been f. 4x plus 7 equals negative 1. Negate 4x equals negative 8. Reciprocate negative 2. Etc, etc, etc. But that's all, even no matter which class you're in, you only had 6 to do. So we move on to the next part. So today was negation and or reciprocation. Turn upside down, change sign. That's just fancy words for them. Negation and or reciprocation to isolate an unknown. And that's one way of solving for an unknown. There are other ways, but this is how we're solving today, by isolating an unknown. Okay, part 3. So we're going to negate the x's, and our policy will be bring that way, and negate the numbers, or at least we'll negate that 2x to give me 3x take 2x. And we'll negate that 4 to give me 1 negative 4. X equals negative 3. 5x plus 3 equals 4x plus 2. Negate the 4x, giving me x on the left, 5x take away 4x. Negate the 3, giving me negative 1 on the far side, that's 2 take away 3. Yeah, these are a mess because they're not really labelled, they're not labelled at all, or at least they can't. So we'll go to question 3. 4x plus 6 equals 2x plus 2. Now there is a little trick that you could divide across by 2 because they're all even, but we won't do that. So 4x, negating that gives me, in other words, taking it this way, and negating the 6, in other words, taking it that way, will go negative 4 because it'll be 2 take away 6 is negative 4. Divide, or reciprocate the 2, pop the 2 in underneath there. That was question 3. Go to question 4 now. So you have 6x plus 7 equals 3x plus 1. 3x is left here, but so that's 6x take 3x is 3x. 1 take away 7 is negative 6. And x is equal to negative 6 over 3, which is equal to negative 2. X plus 8 equals 7x plus 3. 2x equals negative 5. X equals negative 5 over 2. Done. Won't go any further. And lastly, question 6. 4x plus 3 equals 3x negative 1. Bring the 3x this way, you get x. Bring the 3 that way, you get negative 4, and you're done. We'll move on.